Hello, everyone, and welcome to our first Behind the Viz, which is an occasional series we're going to run where we take a look at the workings behind a very iconic visualization. So first off the bat, we have Seffana, who's going to be going through and talking to you about her Simpson's Predicts the Future Viz, which went absolutely viral and got picked up by FastCompany and CNET and was all over Reddit. It's a really fantastic viz. So Seffana's going to go ahead and tell us a little bit about how she built the viz, the inspiration behind it, touch on where she got the data, and would love to hear from you. So I'm going to be running all the comments in the chat. My name is Sophie Sparks, and I'm the community manager here at the Information Lab. So if you would like to say hi, please do in the chat box, and Seffana will also be able to answer any questions you have by dropping them into the chat. And who is Seffana? If you don't know her, I will post the link to her on Twitter. She is a current Tableau public featured author, and she's also one of our fantastic data schoolers here at the Information Lab and Data School. So Seffana, I'm going to put myself on mute, hand over to you, and let's get started.
Thank you very much, Sophie. Hello, everyone. So I'm Seffana, and I'm part of the data school, and I'm currently a Tableau public featured author, as Sophie kindly mentioned. And I'm part of the 12th cohort at the data school. So I started back in December 2018. It seems like a lifetime ago. So tonight I'm going to be talking to you about the Simpsons Predicts the Future viz. So I posted it, I think, like a month ago, and I think it sort of blew up on Reddit. I posted it on Reddit on a Sunday afternoon. Whilst I was building, I was just kind of binge watching Hawaii Five-0, and then just out of nowhere, I kept getting a lot of upvotes. So upvotes is quite similar to likes on Twitter. I'm still not quite familiar with Reddit, so I'm just figuring out as I go, so I don't actually get it still. But it just blew up on the Data is Beautiful subreddit. So yeah, and I think it got so popular out of nowhere that even CNET and FastCompany sort of spoke about it in their articles, which was quite weird to see that they're going through my viz like that. I think, oh yeah, and here's the FastCompany one. So yeah, it's quite nice having that there. But anyways, back to the viz. So the way that this viz came about was quite just a random thought that came to mind. So when I was in uni, I really loved looking up conspiracy theory videos. So I used to watch Shane Dawson a lot. So that was my guilty pleasure. I really liked looking up stuff like the Illuminati, or how politicians are basically lizard people, all of that random jazz. Also the Mandela effect, I was all over it. And one thing that kept cropping up was that shows like The Simpsons and Family Guy, they tend to have episodes that they air, and they have obscure things that happens in these episodes that later turns out to be true. Sometimes it's next year or a few years down the lines or a whole decade. So it came up to mind again recently, and I just thought, like, oh, it'd be so great if I could just have a bank load of all of these predictions that The Simpsons have, because The Simpsons has been going on since, I go back, it's like, I think that's the season premiere since the end of 1989, and it's still going on. So I thought if I could just get all of the predictions that they've had made in random episodes and find out when these predictions had come true, I'd really like to see that in the same space and actually see how long each of them had taken. So the way that I got the data for the predictions is just simply self-research. So the way that you navigate this is that you can just pick on any of these curvy lines. These are basically sigmoid curves. And then it'll just update to show what you've selected, and it'll update what the prediction is, and it'll give you a brief description at the top of what the prediction is about. You can do that for any of the lines and so on. Then the other notable feature is at the bottom, you actually have the individual episodes that have predictions, which are these lines. And you can see that they are bucketed by the year since it had come true. So that's basically the date difference between the prediction air date and the year that the prediction had come true. So basically the difference between these. And then also you can actually click on any of these dots that you might be interested in. So if you actually want to see the prediction about the shard, you can click on that and you can actually see the line. In this case, for the shard, this is season 6, episode 19, which is Lisa's wedding, because that was a futuristic episode. So they did make some weird obscure predictions on what happened in the future. So for that same episode, there was 4 other predictions that I had picked up on. So yeah, so just to sort of quickly clarify again, so each of these lines is basically, it spirals from the air date of that particular episode that would have a prediction. So in this case, it's Midnight RX, season 6, episode 6. Season 16, episode 6. I'll start from the air date and it'll go all the way down. So it's easier to find. It goes all the way down and actually was released in 2018. And it had, which is a 13-year difference between its air date and the year it came true. Okay, so let me show you how I actually collate. Oh, I should probably give a shout out to Ellen. So where I got this little blinking dot is from her. If I can actually find it. Have I stopped sharing, Sophie?
You have, so.
Okay. Sorry, that stop sign is so. I can find it. So yes, so this is her peep show viz. She's done this blinking little blip for these circles in her vizzes as well. So it's not only this one, she's done it for various other vizzes that I actually thought was pretty cool. But yeah, I liked it so much that I carried the sigmoid thing forward into another viz shortly after. So this is just looking at discoveries made in the Islamic Golden Age by Middle Eastern countries before their Western counterparts. So that's like an alternative data set using similar chart types. But yeah, so back to the data where I've actually collated the predictions. Basically went on Excel and I went on YouTube or Google or just even Reddit. There's a subreddit called Simpsons Did It or something, which I actually discovered after I posted it on the Our Data is Beautiful subreddit. But there's various places online where people love going into the Simpsons episodes, not just the Simpsons, but various other shows. Just say like in this episode, you'll see that, for example, here, it's about the covering Michelangelo's David. That was something that sort of happened in a really early episode of The Simpsons and actually did similarly happen in real life. I should note that some of these predictions are really weird and obscure and probably faffy, but not to be taken too seriously, but it's just fun. So I have the episode tag, which is basically season number and its corresponding episode number, the description of the prediction, and the year it had come true. So I take this Excel and I write it up and I make sure I stick to the structure because I want to make it as less complicated as possible. And then I put that into Alteryx and I load it into Alteryx. So this is the workflow that I have built. I think at the end of this, I will share this workflow so that other people can actually take it and pick it apart and see if they can build the sigmoid function as well. I'm afraid that there is no free version of Alteryx, so only people that do have an Alteryx license and has Alteryx Designer can actually go through this workflow. But yeah, so for those who don't know, Alteryx is a self-service analytics tool that just that accelerates your ETL workflow and is really amazing at manipulating and transforming your data. So here on the left, I've loaded in the predictions table, as you can see here, and then you can actually see a preview of the data. So I've got the episode tag, I've got the prediction, and I've got the year that it has come true. So kind of had to clean this up a little bit here. So what I've done is from the past folder, I took the text and columns tool, and I wanted to separate the title of that prediction and its remaining description. I realized that when I was writing up this Excel list, I didn't actually separate them. I actually kept it in one space. So I was like, well, I'll fix that in Alteryx. And I did. So the way that I've done that is I've taken the column that I'd like to split. In this case, it's the prediction column. And my delimiter would be the first full stop. And the number of columns would be 2, because all I want to do is separate the first sentence which would be the title of my prediction, and the remaining stuff will be the description. So the next important thing is, what do we do with the extra characters? There are multiple options. You can drop extra without warning, so that will just discard everything after the second period, or drop extra without, so that there's with warning, so you'll just get a red alert when that happens, or without warning, where you're not warned at all, or error, which basically means that the workflow won't run properly because that's you're flagging that as an actual mistake. What I instead opted for is leave extra in the last column. So anything after the last period, the second period, or the second full stop will still be wrapped in to the description. So that's what I've done, and I separated them. And the output root name I've left as default, which is prediction. So it'll be prediction 1 and prediction 2. If I split the columns by 3, then it'll be prediction 1, prediction 2, and then prediction 3. So you'll see that there's a lot of trailing spaces and leading white spaces in this, so I want to clean that up. Easiest way for me to clean that up is going into the preparations folder and just taking the data cleansing macro tool. And then I just want to remove leading and trailing white space, so that you can see that's all there. There are some cells that would have this red indicator, but that's just showing that it has truncated characters. That doesn't mean there's actually anything wrong. So now that I have this, I've removed the original prediction field, which is this. I don't need that anymore since I've done the splitting. And I renamed my column headers back to, so the prediction name, which is left it as prediction, and the second column, I renamed it to description. Okay. So the next tool is the formula tool. So this is when I actually build out the coordinates for the two, for where the predictions are at the bottom over here, which I will go into detail in a minute. So I'll park my description of how I got the 2x and 2y coordinate. I'm going to first move on to how I prepped the data for all of the Simpsons episodes, which is everything at the top here. So these are all of the episodes and their air dates. So here is the table, which is the Simpsons episode CSV file. So I've got a data set with all of the Simpsons episode, right from season 1, episode 1, all the way up to season 31, episode 22, which was aired like a month ago now. So I've got the season number and its respective episode number and its episode tag, and I've got the name of that specific episode and its air date. And then I've just put in a record ID tool, which you can find here in the preparations folder, just to sort of give a unique ID for every single episode across the entire series. Pardon me. So now I go into the formula tool, and now I've also got the from X coordinate and the from Y coordinate. Very similar to the formulas that I have here. Okay, so now I'm going to go into how this actually came about. So it's easier for me to describe these formulas with a simplistic view of the sigmoid. Next to it. So the way that I've done the from X is basically the date difference between the air date, so the day that an episode has been released, and the series premiere. So that, in this case, the series premiere of the Simpsons was on the 17th of December, 1989. And I wrote a little comment over here to sort of document my work if anyone wants to pick up that this is basically the days relative to the series premiere or the first episode. And the coordinates for the Y is basically 1 because, oh, sorry about that. So because I basically want all of the episodes across the series to all sit on Y equals 1 on that axis here. I just want it to be right next to each other along. Okay, so, and this is just basically my description of how I wanted the from coordinates to work. So it's just basically X of air date by 1. So to get the 2x and 2y, similar to the from X and from Y, where I just basically want to take the date difference between the year that the prediction had come true and the series premiere date as well. And I want the units, like in the first one, to be by day. So any prediction would be the x coordinates of the year that the prediction had come true would be in sync with the x coordinates of the episode release date, because they're all relative from a fixed point. The fixed point being the day that the series had been released. And here you can see the way that I wanted to fashion the coordinates is just basically x of prediction year and -1, because I want all of the predictions to sit across y equals 1 along the x-axis. And here's just a preview of what the results looks like. So next, you'll want to know, how do I actually find the coordinates and map out the sigmoid line? So do that by here. So I've got the sigmoid function, which let me just show you where this is in the Alteryx workflow. So I've got that here, where I use the generate rows formula tool, which you can find in the preparations. But again, I'm going to switch back to PowerPoint, where I actually have the sigmoid curve next to it, so it's just easier to explain what you want to show. Okay, so generate rows tool. So with the sigmoid function is basically the function of t, or sig of t, which is the y-axis in this diagram here, is equal to 1 over 1 plus exponential e to the power of -t. And I've chosen to have, I wanted to go from -6 to +6 to have this smooth curve, because that's the condition across the t-axis or the x-axis, where the curve goes from 0 to 1. So I wanted to get the individual points that goes from -6 to +6 along the function of t. And to do that, I first need to get the individual t's across this axis. So what I've done is taken the generate rows tool, and my initial expression will be -6, and I want to go up to +6. And I want my loop expression to go by increments of 0.25. As you can see, I've got those increments going here from -6 to, I'll go to 6 afterwards. It just sort of chops off afterwards. So yeah, so that basically gives us these individual dots. But the way I get these coordinates to work is by actually getting the t and putting it into the sigmoid function, which I've done here in the formula tool. So I've taken the formula of the sig function and put it into the formula tool in Alteryx, 1 over 1 plus the exponential to the power of -t. So that's just the syntax of how to use both the power of function and the exponential function. And also, quick shout out to Alex Jones, who is a DS data school alumni. He was part of the 6th cohort. He helped me build the sigmoid function when I asked him for help for a different personal project that I haven't released on Tableau Public yet. Who then told me that Philip Mannering, who also is a data school alumni, he was part of the 5th cohort and who's now working at Aimpoint Digital, who he helped Alex with the sigmoid function as well. So just a little nice way of helping everyone out. So back to sigmoid, what I've done is that I've actually found the sig function from -6 to 6. So basically all the individual coordinates that make up this curve. And as I was saying earlier, so the increments that I went for is 0.25. This is just an arbitrary number. It doesn't have to be, it doesn't have to be 0.25. I've gone mad with the spinning wheel on my mouse. But the loop expression, the increments doesn't have to be 0.25. It's just an arbitrary number. It could be 0.01, it could be 0.1, 0.5, and so on. But the thing is, the more smaller your number, the finer the number, the more data points that you have. So when you start connecting the dots, the curve becomes more smoother. But some people might go mad and try and make the numbers much smaller, like 0.001 and so on, which would work, which would make the curves look really, really small, smooth, sorry. But if you do that, you are also introducing a lot more data points. And when you have that on Tableau, your dashboard will be slow because it's querying a lot of data marks. So for me, the 0.25 was a reasonable number where the curves did end up looking quite smooth on Tableau and Tableau Public and didn't hinder the performance in a noticeable way. So that's just how I got the sigmoid coordinates along the curve. So before I go on to how I've actually got this the sigmoids to work for each prediction, because they all have their own sizes and widths, I'll just go back to the workflow to show how I actually joined the predicted episodes and its sigmoid function to the other episodes. So I've got T, and I've gone through how I've done the formula here. And what you'll find is that because I've gone from -6 to 6, you'll find that from -6, which is the lowest number, you'll see that the sig function is actually equal to 0.002 and so on, which isn't exactly 0, but really close to 0. And if I go all the way down to the uppermost number, which is +6, you'll see that the sig function is 0.9975 and so on, which is really close to 1, but isn't actually 1. So what I have here is just brought in text input, which you can find in the in and out folder, and just made my own little table with the same column titles, index, T, and sig. And I've got 0 and 50 as my index. Index just basically means the dots, the positions of the dots, coordinates. And I've given it a T value of -6.1 and 6.1, and just given it a value of sig of 0 and 1, just to sort of round that off. So we don't have values that are really close to 0, really close to 1. We have definite numbers. Just union them so they're right on top of each other. And then what I do, so actually I'm going to park this sig for a moment. Now I'm just going to go into how I actually do match the predictions to the episodes. That is done by bringing in the join tool, which you can find in the join folder in the top ribbon. I bring that up, and then I basically join both all of the episodes from The Simpsons and all of the episodes with its predictions that I've come up with, and I'm joining it by specific fields rather than record position. So the fields that I'm conditioning it on is that the left input, I want the episode tag column to match the episode tag column in the right input anchor. And then I've unchecked the right version of right input anchor, just because it'll just repeat itself because it's got the same, they're both exactly the same fields on both sides, and they'll just be repeated. So I don't really need that. Okay, so everything that comes out of the J anchor, the join anchor, basically means that all the predictions have been basically only for the predictions, the episodes with the predictions exactly matching the episodes in the episodes they've said. Anything that falls out of the left anchor are basically the episodes where I didn't find a prediction for in my Excel document. Okay, so I'm going to leave the others that I've labeled it as, the other episodes that don't have predictions for the time being. But what I am going to do is take episodes where they do have a prediction with its descriptions and so on, and append the sigmoid function to it, because I want to map out the coordinates for each individual episode with their predictions. So just append it. You can find the append fields tool here in the join folder. So my target will be the episodes with the predictions, and my source will be the sigmoid function. You can see that I've documented that here as well. So I've got all of that. So you'll see that I sort of exploded the data set because basically I just want each individual row to have, each individual episode to have its own sig value as well. And then I just union the other episodes from the left-hand anchor to the episodes that have predictions and now have the sigmoid function. So yeah, you can see that they're right on top of each other. So just to point out that the episodes of the other episodes, when you find them in the out of the union tool, they will have null entries naturally for indexed key and the sig columns because they weren't appended here below. So just something to watch out for. Okay, so this is where we're coming into the part where I need to produce the XY coordinates for each sigmoid curve. I use the select tool just to change the field types of the from X and the from Y fields. For some reason, I think they were read in as strings, so just had to change them to integers. So this is where the rest happens for making the X and the Y coordinates. Again, I'm going to go into my PowerPoint deck just so that it's easier to go through visually with a sigmoid curve next to you. So here I've got the sig function again, and I just want the X coordinate for each sigmoid curve for each individual episode. So what I've said is for X, if not is null sig, so that basically means that there is a prediction for that episode. I know it's a little confusing to read because there's a double negative, but as I was saying earlier, the episodes that don't have a prediction will have a null value for sig. So if not is null, then give me the difference between the 2x coordinate, which you'll find here, from the from x coordinate, and multiply it by its sig value, and then add that to the its original from x value. So you want to offset it by its from x value. So if, like, for example, 2 of x minus from of x, and if the sig was 0, where it would be right at the top, then that will be 0. And then if we add that from its from x, it'll start here. And then as you go down at little increments, I'll just add by 0.02473 and then 0.03173 to its original from x, as you can see here. Okay, and a very similar structure to the y coordinate of the sig curves for each individual episode. So again, if not is null sig, so there is a prediction for that episode, then take the difference between the 2 of y coordinate and the from of y coordinate and divide that by 51. The reason why we're doing it by 51 is because there's 51 entries in the index. So there's 51 dots, 0 to 50, and then multiply that by its index. So these are just to illustrate that these are the index values, 0, 1, 2, 3, all the way to 49, 50. Else, if it doesn't meet that condition, then we'll just give it its original from x value and from y value, so it stays at the top, because that basically means that it didn't have a prediction, so it just stays here below. It doesn't need to come down, or it doesn't need to have a curve. So that's pretty much it with how to actually build out the sigmoid function. Like I said earlier today, earlier in this video, I will try to upload a link so that you guys can download this workflow so you can go through it. Hopefully it's documented well enough so that people can understand what's happened and so on. But if anything, just shoot a comment on the video, and I'll try and trying my best to see it properly and then answer on time. But yeah, so I then run that, just reordering fields and get rid of anything that's unnecessary. I run that and I output it. In this case, it's coming out to a temporary location. That's because this is the workflow that I'm going to upload online so that you guys can change it to whatever you want. But yeah, so then I output it as a CSV file. Then we move on to Tableau. So now I'm going to build the predictions. Let's use some water. So now I'm going to start building the sigmoid curve that we all are quite familiar with now. So the way that I do that is by finding the x, y values that we made here. And I'm going to bring that into the view. So I'm going to right click sorry, I'm going to go on this, move my cursor over X, right click and hold, move that and drop that onto the column shelf. And that's just a shorthand way of just bringing up this way to aggregate measures option. You can also do that with date fields, and it's just a quick shortcut that I love. So I'm going to do min of X. I'm going to do the same thing for Y. Right click and drag, put that into rows. Min of Y. Want to make this an entire view. You'll notice that this is really blank in the sense that there are no grid lines. That's because I personally do not like grid lines. So the way that I've done that so that it doesn't show up is I've gone on format, workbook, and you can see that there's grid line, and I've just turned it off so that whenever I build anything with using measures or a chart, it doesn't show up. You can do this. I can get rid of the axis rulers if I like, and so on. So this is something that I found out a couple months ago that I wish I had known really early on, because it's a faff to just always go onto format and get rid of grid lines and so on for every new sheet that you build. But anyways, so that's just a quick side tip. So back to the actual vizzing. I've got the min of X coordinate and the min of Y value in the row shelf. So now to actually break this up, I'm going to put in the episode tag, which is each individual episode. I'm going to move that, and I'm going to put that onto the details shelf. So here you can already see that these are all of the episodes with the air date. I think I'll just put episode name as well, so it's easier, and probably put the air date onto detail as well, so I can actually see when it came out. Year of air date. No, I don't want year of air date. I want the exact date. Yeah, cool. So it's easier for me to read. Okay, so now I actually want to bring those curvy lines that we all know and love. So that's here, the sig. I'm going to bring that onto detail. So it's got these really funky looking circles. That's because Tableau has defaulted it to shapes. I don't want it to be shaped or circles. I want it to be a line. And I want the path to be led by the sig field. So the way I do that is just clicking on this icon and then just moving it to path. I mean, to be honest, I could have also just moved that to path, but sometimes I find that a little easier by pressing it here. Okay, so I've got that. So the other thing that I wanted to do is that to actually select an episode and find their description. So the way that I wanted to do that was using parameter actions. And as the name suggests, if I have parameter actions, I actually need parameters. So I've got that set up here. So here is my parameter, conveniently named episodes with predictions parameter. So these are only going to look for episodes that do have predictions, which is a calculation field that I made. And I've had it to when workbook opens. So this is dynamic parameters. I think this is a feature that came out in 2021, I think, or I don't remember, but it's a recent feature that they were speaking about in TC19 as well, and it's great. So the reason why I've had it to when workbooks open rather than fixed is because sometimes whilst I was building this in Tableau, I in my break or whatever, when I took, I don't know, when I couldn't bother to viz this, I'd find out other predictions, and I'm like, ooh, okay, let me quickly add this to the list, and then I'll have to rerun the workflow, and then whenever I reopen this this viz, then I'll automatically bring in the new episodes that fit under that criteria. So that's this. So that's that parameter. I'm going to put that into the view, and to color it, I've got a field here. So this is just saying if the episode tag, which is this field that I have on detail, is equal to the parameter, which is this, then label that as selected prediction, else other. To be fair, after doing this viz, I realized that this really could have just been a Boolean, which is what I did in the Islamic discoveries viz. I don't have it anymore. So that was Boolean, but over here I kept their strings. Booleans are actually better. They're more performance friendly than if statements. But yeah, but on this occasion, I had it as an if. So yeah, so that's basically going to be my size and color field. So I'm going to plot that onto color. The problem that I have is I don't have the color legend. So I'm just going to go on analysis, legend, and up. The issue that I have is that currently the blue, which is my selected prediction, which is season 4, episode 8, is behind all of the yellow lines, and I don't want it to be. I want this to be first. So I'm just going to drag that up. I kind of want this to be a little bigger. These lines are a bit skinny, but also I want the blue line to be a tad bit bigger than the yellow lines. So what I'm going to do is I'm going to hit press Control. If you're a Mac user, then it'll be Command. I'm going to press Control, click on my size color field, and I'm going to drag that and plonk it on size. So that just is an easy way of copying and pasting fields. So yeah, so I've got Tableau resizing it properly. So I think I'm cool with it. But if you, I've had it on reversed, but it'll default to this typically in this order. But if ever you find that you've got it like this and you try to rearrange, this will also be in sync with the color legend. So this is why I had selected above other, so that the color of the selected would be on top of the other colors. But then all you have to do with the sizes is just check reverse. So there's that. The other thing that I found with this one is that I'm not particularly a fan of the way that all of the colors blend together. It's hard to make out individual lines. So what I can do is just reduce the opacity. So I'll make that 60%. Okay, cool. So I'm going to clean up the tooltips because I'm not really liking any of this. So I could put the other thing I don't like is that when you click on a tooltip, you get this keep only, exclude, and this group thing. I'm not a fan of that. So just gonna episode name, tag. I'm gonna make this a bit bigger, 12, not bold, and then yeah. So I've got that. Also, you'll notice in the main viz that I've got the description here. So in this episode, the selling ferrets is toy poodles prediction, released on the 28th of May, later became true in the year 2013. But when you move up, you'll see that those episodes that don't have predictions actually have a different tooltip. This is because I've made the tooltips a little dynamic. So as you can see here, I've got 3 calculations for the tooltips here. So currently I've only got the episode name and its episode tag. But I'm going to move these 3 onto tooltip. Oh, and to get rid of that keep only and exclude thing that I was showing you earlier, I'm just going to uncheck include command lines because I'm not a fan of that. So 1, 2, 3, conveniently named, just so I know the order. Hopefully this works. Okay, cool. I should also add a prediction onto detail because there are some episodes that have multiple predictions in an episode, like Lisa's wedding. So you'll see that in this episode, the bloody billboard prediction released on the 3rd of November later became true in the year 2008, but it's different when we go above here. So I should probably open up this tooltip window, calculated field. So this one's just saying if not is null. So similar to what we were doing in Alteryx, which is basically if there is a prediction, then just say in this episode the prediction released on blah blah. The next part would have been the date, and then if it's not prediction, then just say this episode doesn't have Part 2 is just the date. For some reason, I really want to put a date in here and I wanted to make it slightly bold, which I haven't done here. Now you can see, I don't know why I wanted to do that, but I just thought, I just wanted to highlight the date. So I've done that here, and there is no else, else will just be blank. And for part 3, which is just the end, it's just the tail end of after the, what's it, the date, just say that. So that's just a really, that's just a, the lengths that I want to go to just to make sure that I have dynamic tooltips. No one has to do these things, but I kind of enjoy little subtle things as that. So now we actually want to click on these sigmoid lines and make sure that we can color them. So the way we do that is to actually enable the parameter action. So that the way that I have this is by pressing Control-Shift-A and opening the action window. So if you're a Mac user, then it'll be a command. So I'm going to go change parameter. I'm going to just say select, or actually no, color selected prediction. My target parameter would be episodes with prediction parameter, which is over here. Field will be episode name. It could also be episode tag. It could also be episode name. We'll just choose tag. And now it'll work. So it works. But then you'll notice that another pet peeve of mine is that when I click on something, all of the other marks fade out unless I click away. I'm personally not a fan of this default feature in Tableau. So what I have is this null highlight to nullify the highlight field, which is basically just a blank entry. And what I'm going to do is I'm going to drag that onto detail. And then again, I'm going to press Control-Shift-A, highlight, null highlight. Just going to give it the same name. Selected fields, and I'm going to select null highlight only, that field. Press OK and OK again, and then I'll click on something else, and you'll notice that nothing else fades out as soon as you click. This is because it's highlighting every single mark in the view, because that null highlight is appended to all of the marks. I've made a blog actually that goes into this for you, so you can actually read up and see how that works and why it works. You can do the similar thing with parameters actions. Shout out to Brian Moore. He's the reason why I know this, trick, and actually Kevin Flelage. Sometimes I mix up those twins. Kevin Flelage actually showed me his blog. It's really, really good, and it's a trick that I use on client side all the time now. So yeah, that's how I've done the sigmoid curves. I'm gonna uncheck show header. I'm not a fan of that. So the other thing that I want to go into was just how I built this. The little blips for all the episodes where the year since prediction came true. So what I will get is year since prediction. That's a calculated field. So that's basically the date difference in year between the air date and the year that came true year field. So that's basically the field from the prediction data set where I've told which year it has come true in. Okay, so I'm going to bring that up, right click, drag it, min. I want entire view, and notice how there's no grid lines because I've done that format where I've got rid of all the grid lines. I'm going to bring episode tag into the view. I do not want this to be bars. Let me make this circles. I don't want borders. Okay. Let me reduce the opacity because you can see that in the bottom left that there's 34 marks. That's because there are, I think, 34 marks. Let me get rid of this indicator, I'm not a fan. But actually, if you look at this, it isn't actually that obvious that there are 34 marks. So if I reduce the palette, if I make this a little bigger, you can actually see that some of them are darker than the other. So if I highlight this, that means I've highlighted 4 of 34 marks. So I need to actually split this because what I want to do is that I want to see how many episodes fit into the year buckets of the date difference between the episode air date and the year prediction had come true for that particular episode. The way that I will do that is by using the index function. The index function is a table calc, and it basically helps have partitions for marks in the view, and it's actually quite great. I think there's the trellis, Chris loves trellis calculation. Trellis chart uses the index function a lot. It's really, really useful. I love it. But yes, so I actually want to split this by the year. So what I actually need to do is actually bring the year onto detail column, and I'm going to put it onto detail. But table calculations, if I edit the table calc, will only compute along with dimensions. But this year field currently isn't a dimension, so I need to make it a dimension. So right click, dimension, click. So now when I open the table calc, you'll see that that field has now been read in as a dimension. So I'm going to check episode tag. So the way that I'll read this table calc is the way that Andy Kriebel, my teacher, has taught me. So for each year's since prediction, so the date difference between the episode air date and the year the prediction had come true, compute the index or the partition for each episode tag. And that's it. So the index goes from 0 and onwards on a positive, but I'm not a fan of how it looks like this, so I'm just going to make it negative. So it actually looks like it's falling down from top to bottom. Yeah, I prefer this view. So actually, I'm going to leave the header there for now. So the other thing that I had is, is that you'll notice that I had the blimps and I also had the colors. So I'm going to quickly add the color here. So I'm going to show you how I made that blimp. So I'm going to add the colors. And how I did this is by duplicating this field. So what I did is press Control and copy that field. And I'm going to dual axis this. And I'm going to go on one of the axes and I'm going to just make one of these circles a little bit bigger. Oh, I need to change this so that it computes across the size. That's why that color was looking weird earlier. So I just need to make sure that it only computes for each year across both episode tag and the size and color field. So I'm going to make sure that I synchronize these axes. Okay, cool. So for this one, I'm just going to make sure that one is bigger. So that's how it was done. So it's already done this for me because I've done it before. But I'm just going to edit the sizes so that this is much smaller. Oh, sorry, that this is much smaller. I don't want it to be that big. Okay, and I want the sizes of this to be a little smaller. Maybe like here. Yeah, like that. That looks good to me. And I want the blip, the bigger circle, just to be a little fainter. So I think I'm going to do 40. And the main circles to be 100% opacity. So that's pretty much it with how I did that. So it's basically just a dual axis of these years since prediction. And one of them will just have something on size, which will be the parameter, the field with a parameter inside. So if it's the selected episode, that will be the one that's on size and on color as well. So I need to set up the parameter action as well for that. Control Shift A or Command Shift A. Go to parameter, select episode. Episodes with prediction, episode tag. Yeah, that's it. I'm going to do the null highlight as well because that's genuinely a pet peeve of mine. Null highlight, select fields. Oh, and then they haven't. I'm just going to select episode tag for now, but I actually need to put null highlight onto detail here. So now I can, so rather than episode tag, I want it on that. So hopefully this works where I click on something and it'll update accordingly. So I can uncheck show header. So yeah, that's basically how I made this. I don't like these dividers, but yeah. So that's how I made these little blimps. That's courtesy of Ellen Blackburn. She's the reason why I know about this. It's a really nifty little tip and design quirk. So yeah, then you put them onto this dashboard. The other thing that I should probably go into, but I don't have time to build from scratch, I guess, I think we're hitting the hour soon, is actually updating the prediction title and the description. So if I go into the description, that is basically fed off by one field, which is a selected prediction episode, which is not a calculated field. That's actually just a parameter. So this field on text is just a parameter. Over here, it's just a string, and I've selected to all. So the reason why I have, so the way that works is if I press Control-Shift-D, so D is to open the action window for a dashboard. So this is prediction description. This is fed off by the sigmoid chart and the, I'm going to call this the blimp chart. Target parameter is the episode description, selected prediction description, that is a mouthful, which is the field on text for that chart. And it's fed off the description field, which I have on detail here. So, so whatever, for each episode, they have a respective description if they have a prediction. And that description basically is fed in to this when we update it. As for the title, similar thing. So if I'm going to go to the title, that is also a parameter that's just put onto the text tool. So that's the selected prediction parameter. Very similar setup to the selected prediction description parameter, where it's a string, allowable values are set to all, and it's just all of, it's just whatever you click on. So again, the setup for that is prediction. It's fed off these two charts again, the sigmoids and the little blimps one. Target parameter selected prediction. And instead, this time, the field is prediction, which again is also on detail in the sigmoid here. Oh, the one thing I forgot to point out here is when I made the parameter for the episodes with prediction, if I edit that one, I could have made it all, which is an alternative to making something dynamic. Because, I mean, if I didn't have the when workbooks opens, I probably would have done all. I could have done that because that would have been no different to how when we're clicking on different marks here, and I've had the parameters that feeds these two set to all, it would have updated the colors as well. Since predicted highlight episode, since that prediction would have been fed by the episode tag, which is on detail on this chart. That would have updated the colors perfectly fine. But the reason why I didn't, sorry, I should go onto the parameter. The reason why I didn't have it set to all is, and I had it specifically for the fields with the episodes with prediction, is because if an end user clicks on any of the episodes that doesn't have a prediction, then that would have also turned blue. And then that would have made the prediction title completely blank. Well, it would have said prediction, but blank. And then this description would have been void as well. There had been nothing. I didn't want that, so I wanted to minimize the confusion. So I've just made sure that the parameter is only for feeding off the field. That is just for the episodes with the prediction. So yeah, that's just how I built the Simpsons viz. Most of the hard work, if I was going to be honest, is actually just collating this information, because that was actually a lot of manual labor. and a lot of hours, but a lot of fun finding the predictions. I really did enjoy that. And also a second to that would be the Alteryx workflow. And again, massive thanks to Alex, and in turn to Philip Mannering for helping me with the sigmoid. And I'll make sure that I share this workflow so that other people can take it and use it. And maybe you guys can reappropriate it for your own personal projects, like I did for the for this one, if it'll load, for the discoveries in the Islamic Golden Age. So yeah, to be fair, I mean, sigmoid lines are probably not the best viz practice. It could have just easily been a straight line, but you know, where's the fun in that? Also, I wouldn't say that sigmoid functions are only able to be created using Alteryx. You can use Tableau as well to create the functions, to create the coordinates. I think Ken Flerlage, the other brother, who's also a Zen master, on his blog site, he has a blog that goes into building the sigmoid function using Tableau. So I don't think he has Alteryx. So that, you know, so if you don't have Alteryx, that's absolutely fine. You're not limited. But yeah, I just prefer using Alteryx because I like to minimize the data prep in Tableau. For me, Tableau is a pro visualization, and Alteryx is, I just want to do all of the as much data prep as possible in here. But yeah, thank you very much. Feel free to download it. This is downloadable, so you guys can unpick and see how I built this. And again, as I said earlier, feel free to leave a comment in the YouTube channel, in the YouTube video, if you have any questions about what I went through. So yeah, let me know. Sophie, over to you.
Thanks so much for that, Seffana. Hopefully I've managed to unmute myself properly. I don't see any last questions coming through except for people asking if the Alteryx workflow would be shared. So yes, we're just coming up to the hour. So if anyone does have any last questions, please type them into the chat box for Seffana. And Seffana, I've got one question for you. I'm just putting the link into that, the viz by the Filage twins, which looks into how to make sigmoid functions solely in Tableau.
Yeah.
So you've kind of already answered this, but it looks like you spent most of your time, not most, but a good chunk of the time building this viz, getting and manipulating the data so it's in the right format, but then also quite a lot of time on calculations to do with formatting. Once you're in Tableau, do you find that's quite normal in vizzes you build, to spend a lot of time on the building quite complicated calculations that do nothing else but make a parameter change color or something like that? How much time would you say, if you're building a viz, how much time percent-wise would you spend on those sort of calculations?
In the early days, when I wasn't a frequent vizzer, or I wasn't actually using Tableau as much, I was still sort of learning. It would take quite a bit of time. But for me, they were worth it because they were the little quirks that for me works, where, you know, clicking on something and having the mark be a different color, for me, that's a really good user experience. No one really pays attention to it unless you're the person that built it. And that's what I want. I want something that people don't really pay attention to, but because they don't need to, because it's made their life a bit easier by how to interact with it. For me, that is worth it. And the reason why I find that worth it is when, for example, when I did look at, if I go on Ellen's portfolio, one of her vizzes, and this is the viz where I found she used this blip thing somewhere else, where, you know, I click on something, and I noticed that the blip come through, and also the ASCII that she has for that particular episode is updated as well. This, you know, little things like that is actually an amazing user experience. The thing is, it can be quite, the calculations can be quite challenging to build, but for me, if the experience is quite effortless and seamless, I think for me it's worth it. Even the things like updating tooltips. So because like sometimes I notice when I look at other people's work where I see that tooltips probably don't make sense for particular marks where they kept it consistent throughout, that's a pet peeve of mine. If it isn't already obvious with the null highlight and unchecking, including command buttons, I'm a person with a lot of pet peeves, so I like to minimize that. Also, actually, with this, for example, I've only got one episode that has a prediction that happened in 1 year. So I actually have a field that goes, so for this one, it took the FIFA corruption prediction 1 year to come true. And others would say 3 years and 4 years, years in plural. So I actually have a tooltip for years as well, where if the year is 1, then just year, else years. So it's just little things like that where I put that in, where they're quite effortless, and I feel like there's some thought that goes into it, and for me it makes a difference. But yeah, it does. So to long-winded way of answering a question, does it take a bit of time in the beginning? Yes, because they're not normal calculations, I'd say, like LODs and so on. You kind of have something, whereas these are more revolved around making a better user experience. But once you get used to it, you sort of pick it up, and it just becomes, it's just second nature. So now, like Booleans, I just know what to do with Booleans and colors, for colors and size, as I did with the Islamic Golden Age one. So if people download that one, they'll see that the way that I built the blips with this, that's just using Booleans, not doing if then this. So you do improve. I definitely recommend doing it if you guys like that sort of stuff. But yeah.
Thanks so much, Seffana. So it looks like there's hope for all of us. If we just practice a little bit more, we will get some of these calculations down pat to make our vizzes look amazing.
Very Andy Kriebel.
We're just on time, so we haven't had any other questions coming into the chat. So thank you so much, Seffana, for giving us your time today and taking us through this amazingly awesome viz. I know, who isn't a fan of The Simpsons? For everyone who's joined, we're going to be running a few more of these behind the viz live streams. We've got, and next up, we have Chris Love, the Zen Master Chris Love, who'll be taking us through one of his vizzes, just confirming the date with him. So that will go up live in the next day or so. So if you are enjoying these, or if you have any vizzes you'd like us to talk to the viz author and get their behind the viz view on things, please let me know in the comments and we'll get around to that. So from me and Seffana, I hope you have a lovely evening. You can always reach out to Seffana on Twitter as well if you have any further questions. I put a Twitter handle further up in the comment stream. And all the links and this video will be live at the same URL where you've tuned into now, and I will update it with all the links in the next sort of 12 hours or so. So thank you so much for joining us. So from me and Seffana, hope you have a lovely evening, especially because we've got people joining in from all over the world, Seffana. We've got Hector from Mexico, so if you're really early afternoon from him. We've got Alam, who's called in from India, so much later in the evening for him over there. So thank you guys for joining us.
Nice. Thank you. And feel free to leave a comment in this video, and I'll try my best to answer if you have any questions.
Perfect. And we will update with the link to the Alteryx workflow as soon as Seffana puts that up somewhere where everyone else can download it or access it.
Yeah, for sure.
Perfect. Thank you so much, guys. And I hope you have a lovely evening. I'll end the stream just around now.
Bye.
Bye.